Okay, I think it's time to begin. Hello, everybody. Welcome back to another ACSL class. Today, we're just going to be looking at some stack, queue, and tree practice. So we'll start out with some review first, do a little bit of practice, and then we'll do a practice Kahoot for, for everyone to do some more practice problems. So start off with the review. It's been a while since you learned this, but stack, as you hopefully remember, it's a last in, first out data structure, and it has three main operations. You have push, pop, and peek. Push, it just adds an item to the top of the stack, and it hides any items that are already on the stack. Pop removes the top or the newest item in the stack, and it returns this value. And if the stack is empty, it returns the special value of nil. Peek returns the current top element of the stack without removing it. And if the stack is empty, it returns the special value nil, as you know. And you probably remember this analogy from last time. You can think of a stack like a stack of pancakes. You can put pancakes on top of this other pancakes, but you can't take a pancake out from the middle of your stack of pancakes or from the bottom. So you have to take the ones on top out first. We also have queues. Queues it's like stack, but it's first in, first out. So it has three main operations: push or in queue, which you'll hear sometimes called. It adds an item to the end of the queue. Pop removes the frontmost or oldest item in the queue and then returns it. And peek, it just returns the current frontmost element without removing it. And if the queue is empty, it returns a special value nil. Sorry, and pop should also say it returns a special value of nil if there's nothing in the queue. And a queue, well, British people already call it a queue, but it's like a line. And you just have people go in line, and then the next person to be served is always the person at the front of the line or the person who's been in line the longest. You don't want anybody to, cut in the line in the middle. That would make everybody upset. And then we have trees. So this was in the last lesson. Trees are hierarchical data structures that consist of nodes connected by edges. And there's like parts of a tree. The root is the top node in a tree, and that just means the root doesn't have any parents. And children are the nodes that are immediately below a parent node. Leaves are the bottommost nodes on every branch of the tree, so leaves don't have their own children. And siblings are just nodes that have the same parent or same immediate parent right above them. So that was the review. If you guys have any questions, you can ask right now. Can we do cookies, please? Sorry, I don't know what that means. I think that you might have done that the previous teacher, but if you want, you can try to explain it. I don't understand peek. Okay, let's go back to peek really quick. Do you mean peek for queues or do peeks for stacks? Stacks. Okay. Oh. Okay. Stacks, peek. So peek, it just returns the element that you just put on top of the stack. So it's just like looking at the first pancake on top of the stack. And you don't need to take it out. You're just like looking at what the value is. Like you open a can of Pringles and then you look at the top chip, but you're not taking it out yet. If you want to yeah, it just does nothing except for check the value. Okay, no problem. Are there any other questions? All right, if there are no more questions, then we'll be moving on to practice problems. And if you have any other like things that you're confused about, at any time you can just ask me, and then I'll try to get to you. So here's our first practice problem. Given an initially empty stack and the following commands on the stack, what will be the next item popped? So try to work this out by yourself on a piece of paper or something. And then when you're done, just type out the answer in the chat. Okay, has everyone had a chance to try out the problem? All right, let's look at the answer. The answer is O, so good job to everybody who said that. And let's just take a quick look at this for ourselves. So, oops. Yeah, so stack. Let's just construct the stack by ourselves real quick. So we push C onto the stack. We push A, and then we pop out an element. So cross out A, S, S, I, and pop, O, P, pop, E, I, pop, push A, and then you pop twice. So then the next element in the stack to be that will come out when you pop it is O. But then if anybody remembers, there is also a faster way to do this type of problem where you kind of keep a mental count in your head and you start at 0, and then every time you see a pop, where you go from the back. Yeah, so I'll just explain it real quick. So you start from the back and then you keep a mental count starting at 0, and every time you see a pop, you decrease by 1. Every time you see a push, you increase by 1. And then when you see a push that brings your mental count to +1, then that push has the element that will like give you your answer. If it's just asking for the next item pop. So if we start at 0 here, we have 0. Pop brings us to -1, -2. Push, so we go up 1 to -1, and then go -2, -1, 0, -1, 0, and then we push, and this one gives us +1. So that means that this push has our element that will be the next popped element. And see, it's O, which is our answer. So if anyone's confused about that, you can just ask right now. And this method does work with just basic like questions where it's just asking for the next item popped. But if it does have a special condition, most of the time you'll have to just write it out and simulate it like manually. Okay, if everyone's clear on that, let's move on to the next question. Oh, wait. Okay, just erase everything. Next question. Given an initially empty queue and the following commands on the queue, what will the next popped item be? So this is a queue, not a stack. So um, remember that you're popping from the front. Okay, does anyone else want to share their answer? Okay, let's go over this together. First, the answer is L. So good job to everyone. And let's go over this together. So Q, it's even more straightforward than stack, I think, in my opinion. You push H, push A, and you pop from the N. So you take out H, push N, S, pop, S, pop, O, L, pop, O, pop, and pop. And then, so then this is the next element to be popped from the queue, which is L. And there's also like a method. I mean, it doesn't save, well, it still saves a pretty good amount of time where you can just count up the number of pops in the commands it gives you. So we have 1, 2, 3, 4, 5, 6. Count up the number of pops. And then we just take out that many pushes starting from the beginning. So take out 1, take out 2, 3, 4, 5, 6. And then this next push will have our answer of L. So that's if you want to save a little bit of time and if you don't want to like have to write out all these letters and cross them out again. Okay. And then we have this tree problem. Find the number of nodes that have only one child in the binary search tree for Space Shuttle. So this one's going to take a while, but um, since it's letters, instead of doing like compare numbers like 1 is less than 2, you can just say like A is before C. So just do alphabetical order instead of like numerical values since they're numbers, since they're letters, sorry. you're bad at if you're really like kind of bad with letters, I'll just put this up for you. So use this to check. You can use this to check what letters are in front of each other. Oh yeah, so for binary trees, yeah, if it's the same, then it's counted as smaller. It goes to the left. Yeah, no problem. Okay, let's go over this problem together. Yeah, so this one is a hard one, but we'll just do it step by step. So our first node is S. We'll just write that up here. S. Sorry, that's a little bit messy. S. Next one is P. And if we look in here, P comes P comes before S. So we write P to the left of S. A comes before S, and then it comes before P. So we write that to the left of P. C, starting with S again, it's before S, it's before P, but it's after A. So go down here, we draw it to the right of A. E. E is before S, it's before P, and it's after A, and it's after C. So write E down here. Then we have another S. So S is, well, it's the same as S. So we go to the left, but then S is after P. So draw another branch like this, S. Okay. H. H is before S. H is before P. H is after A. So we go down to the right. After C. And it's after E. So we draw H down here like this. Okay. We have U. U is after S. So we draw U over here to the right. And then we have T. T is after S, but it's before U. So T goes over here. And we have another T. So after S, before U. And it's the same as T. So it goes to the left. So, okay. And then we have L. L is before S. L is before T, if before P. It's after A, after C, after E. And it is, if we look over here, L is after H. It's all the way down here. So we're running out of room. And then finally we have another E. So before S, before P, after A, after C, and it's the same as E, so it goes over here. Right? And now we just need to count up all the nodes that only have one child. So if we look at S, S has two children, but P has two children. A though, A only has one child. C only has one child. E has two children, but H only has one child. And then this E has 0 children and L has 0 children. And then S has 0 children over here. Let's go down the right path. U has one child and T has one child, and this T has 0 children. So it's just these 5 letters that have one child. So the answer is 5. So, I mean, does anyone have any questions about how to do this problem? Okay. Yeah, I think most of you guys' confusion probably came from just forgetting like how to build the tree. So, all right. I think that's the end of our slide practice problems, but now we have the Kahoot. So let me just erase all this first. Okay, yeah. Sorry, hold on. Okay, well, okay, let's move on to the Kahoot. I'll stop sharing my screen real quick. All right. Okay, so this is just gonna be a quick Kahoot. Oh yeah. And Code should be in the chat in a second. Okay, we only have 10 people. There should be 5 more people. You guys should just join to get some practice in. Is anyone else still trying to join? Okay, if not, let's just begin. Okay, please submit an answer soon, or else we'll just have to skip. All right. So the 2 correct answers were browser backward and forward buttons and undo mechanisms and text editors. So the reason why these 2 were the right answers is because for browser, forward and backward, you only need to really like put the web pages that you visited on top of each other. You don't need to be put them in between, because that's not how your history works. So when you go backwards or go forwards, you can just be, when you go backwards, you can just take out the top element of the stack and store somewhere else. And go forward, you're basically adding on the new website. Undo mechanism text editors, it just saves each of your edits as another element in the stack. So like if I type A and then I want to get rid of it, it's really easy to just take out the top element, which was that A, to undo it. And then after you take out the A, the edit you made before that will be ready to take out and then undo. So let's move on to the next question. Good job, everybody. Uh, yeah, so print spooling is just when um, someone else is printing a document and then you print a document, your document has to wait for the other document to finish before it can print. Okay, we're gonna skip in 10 seconds. All right, supermarket checkout and print spooling. Um, well, when you see the word queue, you can just think of a line, and supermarket checkout, well, everyone's waiting in a line to get their stuff checked out. And print spooling is, well, I explained that. So your documents are basically in a line to get, waiting to get printed out. Okay, we'll be skipping soon. So make sure to just put down like any answers, even like just guess if you're not sure even. That way you can get some points at least. Okay. So organization hierarchy and family genealogy. So organization hierarchy just means like, I'll annotate real quick. You have a boss, and then I don't know, the boss has like some team leaders, and then these team leaders have their own like subgroup mates that they need to lead. And you can see that this looks like a tree where the boss's children, quote unquote, not really children, are the people that they directly are in charge of. And then these people are in charge of their own people. And then family genealogy, it's more or less like, oh, it's kind of just one side of the family, but you do have like, you do have a grandpa. Oh, whoops. Oh, ooh. You do have a grandpa, and then, this grandpa can have two kids or two sons, I guess, and each son can have their own children. So it's still a tree. The grandpa, like this, in this situation, the parent-child node thing makes even more sense. Anyway, so let's move on to the next question. Okay, so the answer was B. Oh, dang it. Yeah, can you press the show media button? Yeah, so let's go over this together. It's a Q, so we take from the back. So L, E, S, pop, M, I, S, pop and pop. You push E, R, A, pop another two, B, L, pop, pop. I'll just gotta go down here, push E, and then pop another two, and then push S. And then you can see the next pop letter is B. And then the faster version is for Q, it's to count up the pops. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 pops. And we go from the front. We have 1, this is the first one, 2, 3, 4, 5, 6, 7, 8, 9. And the next push is B. That's how you get your answer. So the other version where you go the other way around, that's for stacks. So you can't do that on a queue. For a queue, you just have to count out the pops and then remove that many pushes from the front. And for stacks, you just have to start at 0, starting from the back, and you decrease by 1 every time you see a pop, increase by 1 every time you see a push, and then when you get to +1, as your count, then that's your push, or that's your answer. Okay, let's move on to the next question. Okay, so just try to cut. I'll put up the alphabet again in case you want a quick reference. There you go. The other version of the popping that goes the other way around, that's do you mean the name of the structure? That's a stack. Yeah, so Q is the one where you pop the one that is Q, you pop the element that's oldest, and then stack, you pop the element that's newest. Yeah, no problem. The number for the root, that's just the first letter that it gives you. So that'd be T. Okay, so let's go over this one together. Here we go. What's the depth of the binary search tree for the constitution state? So our root is T, that's the first letter. I should write smaller. Root is T. H is before T, so we draw H to the left. E is before T, and it is before H, so draw that to the left. C is before T, it's before H, it's before E. Draw that to the left again. Oh, here we go. And then we have O. O is, yeah, it's still before T, but it's after H. So when we go down back, yeah, go down to H, we go to the right this time. N, N is before T, it's after H. So we go to right, and N is right before O, so we go to the left of O. This. I'll try to line these layers more. Okay. S. S is before T, it's after H, it's after O. So go to the right. Should be crossing these out. And then we have T. T is the same as T, so we have to go to the left. It's more than O, or it's more than, or it's after H. It's after O, and it is after S. So T goes over here. I is before T. I is before T, and it's after H. It's before O, and it's before N. So I goes over here. Sorry, this is a bad color. There we go. Okay. And then T, well, just go down this path again. T is the same as T, so goes to the left. It's in front, after H, after O, after S, and down here. It's the same as T, so we go down to the left again. U is, let's look at U. U is after T, so right up here, we just go after to the right. You have another T, so taking the same steps here. Oh, oh. So before, so after H, after O, after S, before, and then put another T down at this very long chain we have going. I is before T. It is, let's check this again. It's after H. It's before O. It's before N. So we have the same. It's the same as I. So we go again up here. O is before T. It's after H. And it's the same as O. So you go down to the left, and it's after N. So we put the O down here. N is before T, after H, before O, and it's just going to go down here. It's after I, so S is before H, or S is before T, after H, after O, over here, and then we have S. Oh, it's going to be crammed. T, well, T, we already know it goes all the way down here to this chain. And it'll just be another T here. A is before everything. So we go to the left. It's before H, before E, before C. So we just have an A off over here to the side. We have another T. We already know that goes down here. And then if I have one last E, so E is before T, it's before H. It's the same as E, but it's after C, so the E goes over here. And then, well, obviously this long, gigantic thing is our deepest leaf. And if we just count up the number of edges between it and or the distance from it to the root, we should have our answer. So we have, sorry, let me get my pen out again. We have we go 1, 2, 3, 4, 5, 6, 7, 8. That's our answer. So this is a very, very long-winded problem. Does anyone have any questions? Okay, let's just go on to the next one. Good job, Andrew. Oh. Okay, we're gonna skip at 1 more minute. Okay, let's skip. Hi, Laura. So we're just practicing some tree stack and queue problems. That All right, so we're almost running out of time, so I'll just go over this really quickly. Here's our alphabet again. Lunar module. L, U, N is after L, it's before U. A is to the left. R is, sorry, it's before U, it's after N. Good. M is after L, after U. Oh, M is after L and it's before U, and it is before N. O is, where's O? O is after L, before U, and it's after N, before R. E is just before L, after A. U is, yeah, U is the same as U. And I do not know my alphabet. U is after N, and it is after R. So just put U over here. L is the same as A, or some L is the same as L, so it goes to A. It's after A, after D, so L is over here. And I have an E. E is before L, after A, and it's after E. E is right after D. It's before L, so E is over here. So number of nodes that only have one child. L has two children. A has one child. U has one child. D has one child. I did not draw this that well. L has one child. This N over here has two children. These two are leaves. They have no children. And these both have 2 and 0. So the answer is 4. 1, 2, 3, 4. All right, let's go to the next problem. Okay, 5 more seconds. All right. And sorry, can you show media? And I'll just go over this super fast. Commands on empty stack. I'll just use the quick method. So this is, okay. This is -1, -2, -1, -2, -1, 0, -1, 0, -1, 0, and +1. So this is our push that doesn't get popped again afterwards. And that is our answer of N. Okay, I'll give you guys, let's say 45 seconds for this one. So you only have until it says 1:35 to finish the problem. Okay, let's skip. Okay, so commands on the queue. Let's go over this real quick. Oh, can you press the show media button? Thank you. So queue is counted up. You have 1 pop, 2 pops, 3 pops, 4 pops, 5 pops, 6 pops, 7. And then let's look at the pushes. This is the first, second, third, fourth, fifth, sixth, seventh, and the next push is this one after the first 7 have been popped, and it's D. And that is our answer. Good job. Okay, 20 more seconds. Okay, answer was 36. So really quickly, let's construct the space station or tree. So S, P, A, C, E, and then have another S over here. T, A, T, and then I, O, N. And then, oh, sorry, N should be on the other side. Okay, and then to find the internal path length, we have to sum up every path length. So this is 2 times 1, 3 times 2, 2 times 3, 1 times 4, 1 times 5, 1 times 6, and 1 times 7. I think, okay, 2, 2, 6, 6, 4, 9. Not 9. What am I saying? 5, 6, 7. And then this sums to 36. Yeah. 2 plus 6 is 8, 14, 18, 23, 29, and 36. Yep. So that is your answer. Let's move on to the last problem. Stack. Okay, so this stack has special rules, so you'll just have to simulate it. Okay, let's go over this real quickly. So this is just a stack, but you can't push on a letter if it's the same as the current top letter. So A, T, wants to another T, but that's not doable. So we skip and pop one, push. Oh, we can't push A because that's already there. And then C, K, pop 2. Oh, whoa. Push O, F, T, pop 1, H, E. We'll skip another E, push M, P, pop 2, push I, R, pop 2, and then push E. We can't do that because there's already an E right here. And then we pop 2. And then the next pop is this one, F, which is our answer. So our final results. Okay, nice. Good job, Dylan. Good job, Daniel. And good job, ETO. Sorry if I didn't pronounce your name right. Yeah, so good job, everybody. Thanks for coming to today's practice for ACSL. I know we went a little bit over time, but sorry for that.
This every week at this time. No, I say
yes,
it's
it
every
should
week
be.
this time. Okay.
Yeah, so yeah, it's every week, Saturday, 6:30 to 7:30.
We will be here next week. Thank you.
All right, thank you for coming.
Thanks, Uma. Goodbye.